High-level physics 1987, question 10. So here we have experiments to find the specific heat capacity of a metal block. We would like to decide which of the following scenarios will make the specific heat capacity measured less than the correct value, or in other words, in this case, the measured C is underestimated. It is less than the actual value. Okay, let me make it a little bit clear, is that the C measured is smaller than the C actual. Now, so considering how do we calculate the C in the experiment, we would use the equation C measured equals to the Q measured over M delta T. Okay, so we'll see what the following errors will lead us to. Firstly, A, the heat loss to surroundings is not taken into account. So if heat loss to surroundings is not taken into account, we had supplied some energy and we would use the joulemeter to measure. Let's say we had measured 10,000 joule of energy that is given by the heater. However, 1,000 joule of energy is lost. Only 9,000 joule of energy stays inside the metal block. Now, when you do your calculation, you use this number because this is measured by the joulemeter. But in actual, the actual amount that stays into the metal block is 9,000 joule. So when you use your calculation, you use 10,000 joule, which means the measured Q is higher than the actual. The measured Q is higher than the actual. Again, you use this to calculate. But actual, we only got 9,000. So the effects will be Q is larger. It would cause C larger as well. So C measured should be larger than the actual. So this is not our choice, not the reason for the specific heat capacity measure to be smaller. Okay, secondly, the heat capacity of a heater is not taken into account. So what does that mean? That means the heater would also absorb energy. Like if the power supply supplied 10,000 joule of energy. Now that 9,000 joule goes into the metal block, but there is still 1,000 joule left into the heater. Now this is similar to what we have discussed. When we do the calculation, we would use the value on the joulemeter, 10,000 joule, but actually we have only got 9,000 joule going into the metal block. So the result is the measured Q would be larger than the actual number. So similarly, we would have a larger Q, larger C, measured C will be larger. So this is not our answer. For part C, statement C, the ammeter measuring the heater current gives a reading lower than the actual value. Okay, so we know that power of the heater is given by VI. If the ammeter gives a lower reading, that means the power is lower as well. When the power is lower, Q is equals to power times time. When the power is lower, Q is lower. So when measured Q is lower, measured Q is lower, the consequence will be we would got a smaller C measured. So this would be the answer. Let's also look at D. The beam balance measuring the mass of the block give a reading lower than the actual value. So that means the measured mass is lower As a consequence, C is equal to Q over m delta T. So if the mass measure is lower, that will give us a higher C. So C measured will be higher, which is not our answer. So the answer is C.